This is Devika Academy. Today we are looking at completeness. Completeness is a unit or a topic in real analysis, and we need to know the definition of completeness and what we mean by completeness as far as real analysis is concerned. So welcome, this is Devika. Make sure you subscribe, share also with your friends. Okay. Bounded set, we start from first definition, which is bounded set. Let X be an ordered set, a subset of S, a subset of S of X is bounded above if there exists a X in X such that an S, if you have an S in S, then S is less than X. Such an X is called upper bound. It's called upper bound. So if you are talking about a X, which is a bounded ordered set. A ordered set, we talked about ordered set from our previous tutorial. We saying if it's ordered, it must be have the flexibility, the flexive law should own, symmetry law, and a transitive law. Those are the three main ones that defines an ordered set. Then if we have a given, this is a subset of S, and it happens that if this X is bounded above, that means as have a upper bound, then there exists a given X which is in X such that if we take a given S, it will be less or equal to a X. In other words, there's no element in X which is greater than this greater than X. So X is the upper bound. S is the upper bound. Okay, let's look at this example here. If this is our S here, that's our set S. So if you take, we have only two elements here, 1 and 4 here. So you see obvious that the highest possible element here in this set is 4, and therefore 4 becomes our upper bound. If you have this n, which we know it's a set of natural numbers, and you find that it includes 1, 2, that way to infinite, it will mean that there is no an element which is greater than the infinite, and because infinite is undefined, that's the reason we are saying n has no upper bound. Let's look at this definition. We let X be an ordered set, and we have a subset which is a subset of S of X. We have a subset S of X. We say it is bounded. This subset is bounded below. So we say this is X is bounded below if there exists a given X, a small x in X, that's an element of X, such that this element is less or equal to X. So this is the smallest possible element in X. This particular smallest element is called the lower bound. So we say that X has a lower bound which is X. This particular X is the particular element which is the lowest of the all. It's the smallest of all in the arrangement in the set. So for example, if you have S being equal to that, you'll see that the possible element which is lowest here is actually 0, and therefore becomes a lower bound. And in this case, there may be, if this is open, if this is S equal to being open 1 like that, it will mean that there is possibility that there is an element in this set which is smaller than 0, and therefore that particular becomes again a lower bound. But if it's not there, it means this 0 is the lowest, the lower bound of this. Is the lower bound of this set. Okay. If you let U be a set of all upper bounds, so if you take all upper bounds in S, we take them and we group them in a set, and that set is the one that you're calling U. Then then the list of all upper bounds, which we normally call the least upper bound or supremum, which is denoted by SUPS. So the list of all upper bound, we call it the least upper bound or the supremum, which is denoted by SUPM. So we are talking all the upper bounds, we could put them down, and the least, the smallest of all, is the supremum of that set. Again, if X is a supremum of set S, then S will be less or equal to X for all S elements in S, and if Y is another upper bound of S, then it will mean that X is still less than Y, because X is the least upper bound, is the lowest of all, so it will still be the lowest. It will still be the lowest. Thus, X is a supremum of S if and only if you take an S for all S in S, which in S in X, for S in X, X for S in X, then there exists a positive epsilon, which is positive, such that there is a S which depends on that epsilon, such that if you take X minus epsilon, we'll get SE. This will be less than the S that depends on epsilon. So this is what we mean. So if you have a line like this, and it happens that this is our X, it will mean that if this is an X which depends with epsilon, then you'll find that this will be the X minus epsilon. So it will be smaller. Therefore, this X here is the supremum. You find it is the supremum. So if this case is true, then that is the supremum of that set. Okay. If you have U being set of all lower bounds, now in this case lower bounds of set S, then the greatest lower bound is called the greatest of all lower bounds is called the greatest lower bound, which we call it infimum, and it's denoted by if of S and GLB of set S. If S is infimum of set S, then this S will be greater than X for all S in S, and if Y is another lower bound, it will mean that X will be greater than that other lower bound, because this is the greatest of all, so it will be greater or equal to that Y. Thus, if that X is our greatest lower bound, if of set S, if and only if for all elements in S, S is greater than X. And for all positive epsilons, there exists a s which depends on the epsilon such that x plus epsilon will be greater than the s that depends on the epsilon. So what do we mean in this? We mean that, remember, x is the lowest lower bound. It's the lower bound. So x is the lower bound in this case. We say that x is the greatest lower bound if there exists a given epsilon which is positive, such that there exists a given s which depends on the epsilon, which is greater, in which x plus epsilon is lower. Okay, is greater than the s which depends on the epsilon. So we have that kind of arrangement. So if you find that a set is saying a set S, it's saying to be bounded if it is bounded above and below. So you say a set is bounded if you find that both sides it's bounded, it has a upper bound and that's a lower bound. So it's bounded in both above and below. It's bounded above and below. Example: if S is this, so you find this the lowest possible lower bound here is 1. So the infimum is S, and the possible upper bound here is greatest upper bound, which is supremum, is 2. Okay, we have another one here. If you have this set here, you'll find that this set is bounded with infimum being 0. The smallest possible lower bound here is 0. Remember, we are talking about natural numbers here. And in this case, m is less than n. So look at this condition here. So if you take all those possible numbers there, you'll find that the only possible lower bound is S, and the highest is 1. Be 1. It will be 1. What do we mean by this? Because if you take, for example, m, remember, is always less than n. So if you take 2, take 3 over 4. So if you go with this arrangement, you can see this. The other one goes to 2 over 4. 2 over 4. It goes this way, and the highest you can go is 4 over 4, which is 2 times 1. So the supremum is 1. The greatest upper bound, the least lower bound, is 1, and the infimum is 210. It's 210. If you go this way, 1 over 4. You see, as you go down, 0. Okay, that's not natural number. So 1 over 4, you see, it is going to 10. That's how basically you check on them literally. Okay, so if supremum of a set belongs to a set, then you say you have a maximal elements of the set. So this is the greatest upper bound. Then if you have the least upper bound, then if you have the infimum of a set belongs to the set, then you say you have the minimum element. You have infimum element. You have the infimum of the elements. So example, if you look at this set here, you can see the possible lower bound, the possible lower bound. Here is the supremum base is 3, and infimum base is -2, meaning 2 in this. Therefore, we have the maximal in it, and we have the minimum being that. But if this one, it is open. It's open set. Therefore, it will mean that 1, it can go less than 1. It can even go more than 3, and therefore you find in this case you can't trace minimal and the maximal element of this. Again, if you look at these 3 here, you find that there is supremum of S being 2. You can see that the high you can go in this is n being 1, and that makes 2. Then the lower you can go, you see it's divided with a big number in n, and that gives you 1. So the infimum becomes 1. And therefore maximum number and minimum number, maximum number can be seen, but in this case you can't really identify the minimum. You can't really know the minimum, so say because it is closed upward, but downward is open. It's open. Okay, so if you have a question on this, kindly leave a comment, and I will be able to check on it. And if you have another question, leave a comment. I will be able also to guide you. Leave a comment below and share to your friends.